Good morning, bachcho. Today we are going to start with the topic of ray optics. My name is Apik Shah and I'm currently a faculty or physics faculty. I'm currently head of department of physics in Career Point in Warangal. Acha. So today's topic what we're going to learn is ray optics. Okay. In our entire topic, or this topic is specifically designed for NEET students. Okay. After going through the NEET curriculum, because NEET curriculum is very basic, we'll move on to the JEE mains and after that JEE advanced curriculum. Okay, okay. First to start with ray optics. What is ray optics? Ray optics is nothing but study of study of rectilinear propagation of light. Rectilinear propagation of light. Now the first doubt I have is what is rectilinear propagation of light? Okay, rectilinear propagation of light is nothing but straight line motion of light, or this line means nothing but straight line motion of light. Straight line motion of light. What do I mean by straight line motion of light? Or what exactly are we going to study in this chapter? In this chapter, we'll start with rotation. Sorry, not rotation, reflection. See, we have seen a mirror. What does a mirror do? Mirror reflects the light, no? So in mirror, what happens is a ray of light strikes a mirror and it reflects back. So we're going to study this property. See, both these rays, both this ray of light and this ray of light are a straight line. So we study this topic in ray optics. Then what more are there? Acha, suppose we see a glass slab, or suppose there is a water in swimming pool. Okay, there is a human. Have you seen in water in swimming pool the human gets shorter and shorter? And why does that happen? That happens due to a phenomenon called refraction. That means the wavelength of light travels to the surface, and instead of continuing in a straight path, what happens? It bends this direction. Okay, those type of things are called, or those type of water surface. This is air, and this entire thing is water. Okay, and this phenomenon is called reflection. Sorry, refraction. This phenomenon was called reflection. Then we'll learn few specific kinds of mirror. What kind of mirror? Spherical kind of mirror. That means a mirror that will reflect from this path, that is shaped like this. Okay, means out here some object will be there, and the question will be asking you to find out the image. Okay, then another type of mirror is this type. An object will be out here, and they'll be asking you to find out in the image. These are called spherical mirrors. Spherical mirrors. Okay, after that what we'll study? After that we'll study something called lens. Okay, a object will be out here, image will be found somewhere out here. Okay, this is called convex lens, and another type of lens, and that is called concave lens. Okay, but this is convex lens, and this is concave lens. Concave lens. Okay, so these are few types of things we'll study in this chapter of ray optics. So my second question comes out to be, Acha, what else can we study? That means our light always travels in a straight path, no? After going out here, sure. That means light should always travel in a straight line. After going out here, it comes like this. After going out here, diverge like this. Okay. So after going out here, converges like this. After going out here, the ray of light after going out here diverges like this. So my question is, light should always travel in a straight line? Somehow yes and somehow no. See, mm, how nobody has seen light travel. Okay, light travels at very fast speed, around 3 into 10 to the power 8 meter per second. So how do we determine the properties of light? Is by conducting experiment. Okay, so few experiments are best explained by the straight line motion of light, and few other experiments are best explained by wave nature of light. Wave nature of light means the light, this ray of light is assumed as a wave that is traveling through this space. Okay, so let us let us do a little brief introduction about wave nature of light. Now what you're going to study is the difference between, little bit of difference between ray optics and wave optics. Okay, ray optics and wave optics. What is ray optics? Ray optics is nothing but rectilinear propagation of light or straight line motion of light. And what is wave optics? The study of the same light, but in case of, but using wave theory. Study of the same light using wave theory. Wave theory. Okay. Out here, in ray optics, what happens is, what they assume is, light travels in a straight line, and whenever it interacts with a medium such as mirror or lens, what happens? It changes its path in straight line. Okay, medium, interacting medium. In wave optics, what happens is, they assume light to be, see, the light is assumed to be what? Hmm. The light is assumed to be a wave, a electromagnetic wave, electromagnetic wave. What is electromagnetic wave? Electromagnetic wave is nothing but an electrical wave and magnetic wave. See, in electromagnetic wave, okay, electric wave follows in this direction, and magnetic wave are perpendicular to the electric wave. Okay, the electric wave and magnetic wave are perpendicular to each other. What do I mean? See this example. Okay, suppose in electromagnetic wave, these are the fluctuating electric fields. That means these are the values of electric field. Okay, and the direction of wave is in this direction. Wave is going in this direction from left to right. Okay, how will the magnetic field look? The magnetic field would look somewhat like this. Okay, that means if the electric field is going in this direction, magnetic field will go this direction. That means electric field and magnetic field are always perpendicular to each other. Okay, this is always perpendicular to this one. That means this plane is always perpendicular to this plane. Understood? So what is the basic difference in ray optics and wave optics? Why are you studying the same light in two different nature? Okay, let's see, or let's conduct an experiment to understand better. So suppose I have an experiment. What is that experiment? Suppose there is a cardboard. Okay, there's a cardboard out here. and there is a cardboard out here. Okay, in this cardboard there are two small gaps. Means I cut out a piece of the cardboard, and in this cardboard also there are two small gaps. Asha, mind you, although the size of this cardboard and the size of this cardboard are same, the size of this gap and the size of this gap are not same. Okay, I haven't said that condition till. In behind the gap there is a screen. Screen means projector type screen. Okay, in front of the cardboard there is some torchlight out here. Let's say some torchlight. Okay, now if we shine this torchlight, what will happen? We shine this torchlight, what will happen? Some will say, since light travels in a straight path, all lights that are passing through this gap will get projected out here. All lights that are passing through this gap will get projected out here, and there will be only two bright spots out here and out here. The remaining all other portion would be dark. Okay, and there is another theory out here that says the light will pass out here and the light will propagate in this manner. Out here it will form a wave, 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 and out here it will also form a wave. That means, and this will interact with each other, and when these two waves interact with each other, okay, at this mid position a bright red spot will form, followed by dark, then again bright red. That means we get a pattern out here. It means bright spot, dark spot, bright spot, dark spot, bright, dark. That means we get a alternating bright and dark pattern. Okay, and out here it says just this portion will be bright and this portion will be bright, and the remaining portions are dark. Now my problem is which one of these theories are correct. Okay, which one of these observations are correct? Actually both of these observations are correct. Our observation depends upon the thickness of this slit. Okay, let's see. The thickness out here is T. The thickness of this is T. Okay, the thickness out of this is T1, thickness of this is T2. If I say, if thickness of slit or thickness of interacting medium is much greater than the wavelength of light, wavelength of light, that means this gap is much bigger than the wavelength of light. It's much very big. Okay, then we see ray optics like behavior or straight line behavior of light. But if this thickness T2 is very small means comparable to wavelength of light, wavelength of light. What is wavelength of light? Here and here. Okay, wavelength of light. Then what happens? Okay, hmm. Then what happens? There is a alternating of bright and dark pattern out here. Okay, then you get wave behavior nature of light. That means if our interacting medium with the light has a comparable wavelength, or the size of interacting medium is comparable to the wavelength of light, we get wave behavior of light. And if the size of our interacting medium is much larger than the wavelength of light, then we get ray behavior of light or straight line behavior of light. Understood? So now we arrive at our first question. Okay, ray optics is valid when the characteristic dimensions are of the same order as the light? No. Much smaller than the wavelength of the light? No. Of the order of 1 millimeter? Can be, cannot be, depends upon the wavelength of the light. Much larger than the wavelength of light. So our D is the correct option. Option number D. So now we start with our laws of reflection. Laws of reflection. And now we dive into the details of ray optics. Okay, what is reflection? See, instead of what is reflection or how is reflection done, see, let us study or how does reflection behave. Okay, see, suppose there is a mirror. Okay, okay, a ray of light is coming to the mirror and striking at this point. This ray of light that came into the mirror is called incident ray. Incident ray. Okay. Now at the point where the ray of light struck the mirror, we draw a line that is perpendicular to both the mirror, that is perpendicular to the mirror. Okay. And that line is called normal. And this ray of light gets reflected back. That means bounces off. And that ray is called, the bounced off ray is called reflected ray. Reflected ray. Okay. Now, two more points out here. The angle that makes between incident ray and normal is called angle of incidence, where I is equals to angle of incidence actually. Angle of incidence, and the angle that makes with the normal and reflected ray is called angle of reflection. Angle of reflection. Okay. Now there are basic two primary laws regarding ray optics. The first primary law is the incidence or angle of incidence is equals to angle of reflection. That means what is basically says is that this angle is equals to this angle. Okay, or angle of incidence, angle of incidence is equals to angle of reflection. Okay, this much is clear, this much is evident. My problem arises, how do I write this, or how do I write this statement in mathematical form? See, in question they won't be asking, they'll sometimes they'll give you the diagram, they'll give you the angle of incidence, but sometimes they must twist the question and that give you the incident vector, incident written as a vector. Okay, reflected ray normal written as a vector and reflected ray written as a vector. How do we find out the relation between these three vectors? Okay, so this same line, angle of incidence is equals to angle of reflection, can be written mathematically by reflected ray vector is equals to vector minus 2 into incident ray vector dot normal vector. Okay, dot incident ray vector dot incident ray vector. Okay, this is our vector formula for, or vector representation of angle of incidence is equals to angle of refraction. Okay, and what is the second law? Second law for reflection. The second law for reflection is the incident ray, okay, normal and reflected ray all lie in the same plane. All lie in the same plane. Okay, the incident ray, normal and reflected ray all lie in the same plane. Acha, what is the meaning of this? Meaning of this is if you turn, or suppose this was our, suppose in a motion. Okay, see how to explain this. Okay. Mm, okay, I'm drawing the diagram. Okay, suppose this was our plane. Okay, this was our incident ray, this was our normal, and this was our reflected ray. If you turn this, if you turn this like this, okay, that means I'm turning this plane such that this side is this side, this side is towards you, this side I'm writing as like this. Okay, then the incident ray, reflected ray, and normal would appear as this line. That means all of this lies in the same plane. In the plane, same plane means this all three rays can be encased by a plane. No, all of this can be encased by a plane. That means all of this can be encased by this plane. That means this plane, okay, contains all the reflected ray, incident ray, and normal. Asha, my question is, how do I write this mathematically? This statement mathematically is written as incident ray vector cross normal vector is equals to reflected ray vector cross normal vector. Okay, any incident ray, okay, normal and reflected ray all will lie on the same plane. That means they are coplanar vectors. Okay, Asha, one more note you must write. Okay, write down a note. From perspective of wave optics, that means in wave optics we have something called frequency of light, we have something called velocity of light, we have something called wavelength of light. So from perspective of wave optics, from perspective of wave optics, after reflection, after reflection, velocity, wavelength, and frequency remain same, but the intensity decreases. Velocity of light, velocity of light, wavelength of light, wavelength, and frequency of light, frequency remains same. That means velocity of light, wavelength, and frequency of the reflected ray is same as of the incident ray. Remains same, remains same, but intensity of light decreases. But intensity of light decreases. Okay. Now, what is intensity of light? What do I mean by intensity of light decreases, or why in case of reflection intensity of light decreases? So to understand that, first we must construct ourselves a mirror. How is a mirror constructed? When a glass is coated by opaque medium on the behind, this acts as a mirror. So what actually happens is incident ray comes, and not the total amount of reflect rays get reflected back. Some amount is gone or sent to the medium itself. Okay, some amount is sent to the medium itself, and it gets sent bounce back in the medium. So this amount of ray of light, this amount of ray of light is getting lost out here, no? So I can simply say intensity of this ray, intensity of reflected ray is much lesser than intensity of incident ray, because some amount of ray is lost out here. Okay, that's why the intensity of light of reflected ray decreases, whereas the velocity of light, wavelength of this light and frequency of this light remains same as the incident ray. Understood? Let's see this question. Okay, a man is 6 feet tall. In order to see his entire image, okay, he requires a plane mirror of minimum length equals to. Acha. The concept out here or concept behind this type of problem is, okay, the concept of here is, in order to see his full image, in order, or let's first draw the diagram. Okay, what does the diagram say? Suppose out here a human is there, okay, and out here a mirror is there. The tip of the mirror, the tip of the mirror is aligned to his head. Okay, so a mirror is there. Now let us assume the height of mirror to be x. Okay, the height of the human is 6 feet. Okay, now the concept out here is, in order for him to see his full image, the light rays from the leg must reach his eyes. Okay, the light rays from the legs must reach his eyes. Okay, and the light rays from the eyes must reflect back. Okay, so this is our main concept out here. In order for him to see his entire image, okay, the light rays, the light rays from his feet, from his feet must reach his eyes, reach his eyes. So these are the concept. So if we see this diagram, okay, if we see this diagram and analyze this geometry, suppose I'm analyzing this geometry, I'm drawing a perpendicular bisector out here. Acha. This light ray, if this is the angle of incidence theta, the angle of reflection also is equal, or the angle of reflection also is equal to theta. So from this triangle and this triangle are similar. So this height is similar to this height. So x plus x is equals to 2x, or this is nothing but 3 feet. This is nothing also but 3 feet. So if this length is 3 feet, if this length is 3 feet, what is this much length? This much length is also 3 feet. Okay, so out here x is also equals to 3 feet, or which is equals to this much length. So our correct answer would be option number D, or 3 feet. Now there is an important conclusion out here. Okay, what is the conclusion? Let's hit on the conclusion. The conclusion of this problem is, in order to see his full image, in order to see the full image, full image, the mirror, the mirror must be at least half the height of the object, half the height of the object, height of the object. That means what? That means if the object is 10 feet, the mirror should be 5 feet. If the object is 12 feet, the mirror should be 6 feet. If the object is 6 feet, the mirror should be 3 feet. The head of the mirror is aligned to the head of the person. The tail of the mirror, they're asking us what is the tail end of the mirror. Okay. Now I have a question. Okay. The question is, how is image formed in a mirror? Or what is the mechanism of formation of image in a mirror? How is image formed in a mirror, in a mirror, or how is image formed in a mirror? Okay, the answer to this simple question is image is formed whenever the reflecting ray are intersecting or appearing to intersect each other. When two or more reflected reflected rays intersect each other, intersect each other, or appear to intersect each other, or appear to intersect each other, images are formed. Images are formed. Okay, my question is, what is the meaning, or what is the meaning of the keyword intersect each other, okay, or appear to intersect each other? See, the keyword between appear and real intersect each other is the difference between real image and virtual image. Or what is real image, what is virtual image, I'll tell you out here. Okay, suppose a mirror is out here. Okay, there's a point object out here. Okay, now this point object will have rays, a ray is coming out here, it is reflecting out here, a ray is coming out here, it is reflecting out here. Now this is the incident ray, this is the incident ray, these are the reflecting ray, these are the reflecting ray. Now my question is, will this reflecting ray and this reflecting ray ever converge or ever meet at a point? No, because they are diverting, no. Okay, but in one condition, if we backtrace them, no, if we backtrace them, they appear to converge. That means they are not actually meeting at a point, they're appearing to meet a point. Okay, and when reflected ray are appearing to meet a point, those type of images are called virtual image. Okay, this is the object. And if real reflecting rays are meeting at a point, then those kind of images are called real image. Okay, so out here virtual image is formed. Virtual image is formed. Virtual image is formed. Why? Because those light rays are virtual, which means the light rays are appearing to meet behind the mirror, or the light rays are appearing to meet behind the mirror. Okay, that means I'm retracing the path. These are nothing but virtual rays. Virtual rays. These are not real rays, These are the real rays. These are the real rays, and I'm tracing the real rays back. So these are nothing but virtual rays. Okay, virtual rays. And one more thing, intersection of reflected virtual rays gives virtual image, intersection of real reflected rays gives real image. Virtual rays. Okay, these are real reflected rays. These 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 are real reflected rays. Reflected rays. Okay, but the problem with these real reflected rays is they do not intersect. They do not intersect. They always diverge. Achha, one more thing. Okay, in case of mirror, whenever any image is formed on the backside of the mirror, be it any kind of mirror, it is always a virtual image. Be it spherical mirror, be it concave mirror, be it convex mirror, when any image is formed on the backside of the mirror. Backside means unpolished side of the mirror. That or that image is always virtual image. Okay. My next question is, what is real image and what is virtual image? What is real image and what is virtual image? Virtual image. Okay. The simple and straightforward answer is real image is the intersection of real rays, real reflected rays, and virtual image is the intersection of virtual reflecting rays. Real image is the intersection of real reflected rays. Always remember, only reflected rays produce images. Incident ray doesn't produces images. Okay, real images is the intersection of real reflected rays and virtual image is the intersection of intersection of virtual reflected rays. That means those rays that are behind the mirror or at the back end of the mirror. That's right. Now my similarly intersection of reflected rays gives the image. So similarly by object of or object principle of reversibility or principle of backtracing, we can simply say that intersection of incidence rays give us the object. So similarly, just write down a note. Okay. Similarly, intersection of intersection of real incident rays gives us real object. Intersection of real incident rays gives us real object. An intersection of an intersection of virtual incident rays gives us virtual object. Okay, by now we have a fairly decent good idea of what is real object. Real object is anything above or on the front side of the mirror. Those will have real incident rays. Okay, real incident rays. The problem is, what is virtual object or what is the example of virtual object? See, suppose this is the mirror. Okay, but instead of my rays coming from a point source like this, my rays are somewhat like this. Okay, these are my incident rays. These are the incident rays. Okay, now out here incident rays produces an object, no, but this object will never meet at this side, but this incident rays appear to meet beyond the mirror, no. So out here there will be an virtual object. In mirror, anything that is on the back side of the mirror is virtual. Okay. Now what we are going to study is properties of image formed by plane mirror. Properties of image formed by plane mirror. Properties of image formed by plane mirror. Okay, so in this topic we're going to study about few properties of image that is formed by plane mirror. The first property is image formed is equal, or image distance is equal to the object distance. Image distance is equal to the object distance. Image distance is equal to the object distance. What do I mean by that? See, suppose there is a mirror. Okay, there is an object out here. Now this object is x distance away from the mirror. Mind you, this distance or this x distance, okay, must be calculated perpendicular to the mirror. Okay, so our law of reflection says that the image that is formed would also be x distance from the mirror. Okay, mind you, this distance x must make a 90-degree with the mirror. Okay, our second law is that image formed is laterally inverted. Image formed is laterally inverted. What do I mean by this? The meaning of this statement is, suppose there is a mirror. Okay, I have three objects, alphabets A, B, C. These are objects. The image of these objects will be somewhat like this: C, B, and A. Why? Because C is nearest to the mirror and our object C will be nearest to the mirror. Okay. Similarly, if there is a hand, okay, and that is being reflected off a mirror, my hand produced will be somewhat in this. Okay, out here, if this was the thumb, out here this will be the thumb. That means my objects are laterally inverted. And my third rule is, okay, nature of image will always be opposite to the nature of object. Nature of image, that means in case of a plane mirror, if the object is real, the image would be virtual, and if the object is virtual, the image would be real. That means object and image are of opposite nature. Nature of image will be opposite of that of object, that of object. And this is valid only for plane mirror. Okay, in case of spherical mirrors or in case of concave and convex mirror, this changes a little bit. That means out here, if my object was real, in case of plane mirror, my image would be virtual. Okay, real object, virtual image. And out here, okay, out here, if my object was virtual or virtual object, out here, my image would be real or real image. Understood this one? Yeah. Now what we're going to study is field of view. Field of view. Now what exactly are we going to study in field of view? See, suppose there is a mirror out here. Okay, there is an object out here. Acha. This object is real or virtual. Say it. Is it front of the mirror or back of the mirror? If it is in front of the mirror, it is a real object. And where will image be formed? Out here. Image will be formed out here or out here. Image would be formed out here because you have to make 90 degree. 90 degrees. So how do we draw the image? We just extend the mirror, draw 90-degree distance as x, and our image would be same distance as object. Okay. My question was not that. My question was, okay, suppose this is an object. How was this image formed? Area of light goes out here, then it reflects out here. Okay. Another ray of light goes like this, it reflects like this. It reflects like this. Okay. If we see these two rays are diverging. So these two rays will meet somewhat out here. Okay. They are meeting out here. Okay. My question is not that. My question is, who will be able to see this image? Okay. Can anyone standing out here, can this person with his eyes out here see this image? See this image? No. Why? Because the reflected ray is not reaching his eyes, he cannot see the image. Why? Because the reflected ray is not reaching his eyes. Okay, he can only see the image when these rays or all the rays between these two rays reaches his eyes. So the only in the position where he can see the image is out here. Okay, if his eyes lies anywhere in this position, he can see the image because there only the reflected rays are going back. So this position or this portion is called field of view or field of view of mirror. Field of view of rays. Field of view of rays. Okay, that means what I'm trying to say is an observer situated outside this field of view zone. Okay, observer situated outside this field of view zone cannot see the image. Okay, so let us write that down. An an observer situated outside the field of view zone. Field of view zone. What is field of view zone? Field of view zone is nothing but this zone. Okay, observer situated outside the field of view zone cannot see the image on the mirror. Cannot see the image on the mirror. Okay, an observer situated outside the field of view zone cannot see the image outside the mirror. Okay, now just write down a note. Okay, and note will form an important aspect of plane mirror. Okay, okay. Every plane mirror, irrespective of size. First write down the note, then I'll tell you what the note means. Okay, the note is every plane mirror, irrespective of size, irrespective of size, okay, always produces full image. Always produces full image. Okay, but as mirror size is increased, the field of view increases. But as mirror size is increased, the field of view increases. Field of view increases. Okay, as the mirror size is increased, the field of view increases. What do I mean by this? See, the simple meaning of this is, suppose there is one object, or this is an entire room. Okay, suppose this is an entire room. I'm drawing an entire room. Now in this room there is a small mirror kept out here. Okay, this room has table. Okay, and a person. What my statement is saying is that even this small amount of mirror, or even this tiny amount of mirror, will produce the reflection of entire room in the virtual world. Okay, table will be produced somewhat like this, and the man will be out here. Problem is the field of view. Field of view means the observer out here. The observer out here can only see this much portion of the room. Okay, similarly the observer out here, the observer out here can see this much portion of the room, this much portion of the room. Okay, so any mirror, irrespective of how small or how big is, it can reflect the whole of object. The amount of object we can see in the virtual world depends upon the size of the mirror. Okay, so the previous question, there was a previous question, no, what is the minimum size of the mirror? The person is the person is 6 feet tall. But there was a question in our previous example where the person was 6 feet tall. Okay, and my question was, what was the minimum size of the mirror? So now I'm saying, irrespective of the size of mirror, the mirror reflects everything. So what is going on out here? See, irrespective of the size, even if the mirror was very small, the total image of the person would be reflected. Okay, problem is his line of sight, or he must be able to see the image, okay. For him to able to see the image, he can only see this much of the image, only the head. Okay, it is a mirror, he can see this much. If we increase the size of the mirrors much more, he can see total. Understood? So the field of view was his eye out here in the previous question. Okay, that means the rays from here was coming out here and going to his eyes. So in order to see the full image, the mirror must be this much length. Understood? But irrespective of the size of the mirror, a plane mirror, however small it is, always produces the full image of the real world in front of it. Okay, a plane mirror produces full image of the real world in front of it. Okay, now our next topic would be field of view of observer. Field of view of observer. Okay, what do I mean by that? That means suppose there is a plane mirror. Okay, out here there is object 1, out here there is object 2, out here there is object 3. Okay, now tell me how many images will this mirror form? How many images will this mirror form? This mirror will form all the images, irrespective of size of object, irrespective of anything. Okay, so image 1 or image of object 1 will be formed out here. image of object 2 would be formed out here. Image of object 3 would be formed out here. How? We have to trace the line and draw a perpendicular distance to the line, and this distance, this object distance should be equal to this image distance. Should be perpendicular to the trace of mirror or the real mirror. Okay. Now my question is, acha, let's erase this line. Okay, it will get confusing otherwise very fast. Okay. Now my question is, will a observer out here can see how many images? Okay, so whenever such type of question comes up, the first step is to draw out all the images corresponding to the object. Okay, image 1 is corresponding to object 1, image 2 is corresponding to object 2, image 3 is corresponding to object 3. First step, only draw the image irrespective of the light rays or irrespective of the path of light rays. Okay, now what do we do? Now draw the observer where the observer is situated. Then what do you do is draw two lines from the extreme of the mirror. Okay, draw two straight lines from the extreme of the mirror, and this portion is called field of view. That means anything that is inside this portion. Okay, this observer can see anything that is inside this portion. That means this observer can see this image 1 and this image 2, but he cannot see this image 3. Okay, so how do I see this image 3? See, in order to see the image 3, what do? We bring the observer close to the mirror. Okay, have you seen, if you bring your mirror close to the mirror, you can see much more of the wall behind you. Okay, how does that occur? See, this observer was very far away, no? Okay, suppose my observer is out here. Okay, see now my field of view. It is very close to the mirror. My field of view becomes, draw straight line connecting to the edge of the mirror from the observer. See, my field of view becomes so large. So all three images are inside the field of view. Okay. Similarly, if what happens when I take my eyes very far away from the mirror, or what happens if I take my eyes out here, it is very far away from the mirror. My field of view becomes very narrow. See, okay, that means right now I can see only this much. I can see only this much portion, only this much portion. Or image 1, image 2. If my eyes was near to the mirror, I could see all the portion. Okay, and this portion is known as field of view of observer. Field of view of observer. Okay, now make a remark. Hmm. In this question or in this situation only, I'm making a remark. Okay, okay. For this observer, for this observer, okay, image 1 and image 2 is visible, but image 3 is not visible. But where is the thing? But image 3 is not visible to this observer, not visible to this observer. That means what? This mirror, this mirror is acting to the window to the virtual world, no?
If you go near to the window, you can see so much more. If you go very far on the window, your field of view gets very narrow. Okay, you can see very less amount of the things. So a mirror, and this is the virtual world, no? This is the virtual world. Everything that is ahead of the mirror will be reflected in this virtual world, irrespective of the size. The size determines what? The size determines the field of view. That means how much can we see at once, or how much of the image can we see at once. Okay, so for an observer, for an observer, okay, the mirror acts as a window to the virtual world. The mirror acts as an window, mirror acts as an window to the virtual world, to the virtual world. Okay,